Hello, hello, hello. So hello everyone, good morning. So good morning, good morning. So I think I'm audible, right? Yes, okay. So we will start lecture number 2 of vector analysis. So in yesterday class, when I checked the video, I think the audio is little bit low, right? So I try to speak loudly, and also I need to buy one new mic that has noise cancellation and it captures sound good. So actually I'm using mic, the webcam mic. So it is not that up to the mark, right? So soon I will buy new mic with noise cancellation so that you will have more audio clarity, right? As of now, for some days adjust with this audio, right? Okay. So I think my voice is audible. It is not like pre. Okay. So yes, so I'm audible, right? Okay. Okay, thank you. So we will so we will start lecture number 2, right? So we will start lecture number 2 of vector analysis. So if you haven't watched the previous video, so go through previous video because it is a continuation of previous video, right? Super. So in the previous class, what we discussed is we have just gone through the syllabus of vector analysis, and then we have given the overview, right? We have given the overview. For that, we have analyzed the last 10 years question papers, that how many questions are coming in topic wise, right? So roughly we have estimated that we have around 60 marks only from vector analysis, and then we have classified the entire syllabus into 6 subtopics, right? So we are in the first subtopic, which is gradient, divergence, and curl. And in the previous class, we have defined what is meant by gradient. After defining gradient, we have seen the basic theorems like what will be the gradient of a sum of two function, product of two function, quotient of two function, right? And then we have seen 4 to 5 problems, right? We have seen 4 to 5 problems. Okay. Okay, right? So I think everything is fine. Okay, so we will start today's class. So we're going to continue solving problems based on gradient. After that, we are going to move on to the next subtopic inside gradient, divergence, and curve, right? So inside gradient, divergence, and curve, we are going to move on to the next subtopic, right? Okay. Okay. So prove the following, right? So we straight away start solving problems based on gradient. So prove the following. So problems. Okay. So prove the following, right? So prove the following. Right, so prove the following. So we are going to prove 6 things now. So that is a 6 subdivision inside this. The first thing is we are going to prove. The first thing is prove that. Okay, prove the following. I'll complete the question first. So prove the following. So yesterday we have solved 5 problems, I think, right? So we will start with this. I think we have solved it. Yesterday, I think we have solved 5 to 6 problems, I think. So just verify. 4. Yes, I think we have solved 5 problems yesterday class. So I'll just write this as 6th problem, right? If R vector is equal to xi vector plus yj vector plus zk vector, and let us define small r to be modulus of r vector, right? So what is modulus of r vector? It is nothing but square root of x square plus y square plus z square, right? Because r vector is modulus of xi plus yj plus zk, right? So when you take modulus, we will have this to be equal to root of x square plus y square plus z square, right? X square plus y square plus z square. Okay. So if r vector is equal to xi vector plus yj vector plus zk vector, and you denote small r to be the modulus of r vector, which is root of x square plus y square plus z square, through the following. Right, so we're going to have we're going to do 6 subdivision under this. So we'll start with the first subdivision. So prove that gradient of f of r is equal to f dash of r into gradient of r. This is the first thing we are going to prove, right? Okay. So we'll start this. Now, we need to prove gradient of f of r is equal to f dash of r into gradient of r, right? Okay. So what is gradient of f? So gradient of f is dou f by dou x into I vector plus dou f by dou y into j vector, dou f by dou z into k vector, right? This is gradient of f. So we will find gradient of f of r. So instead of f, you replace by f of r. So it will be dou by dou x of f of r into I vector, dou by dou y of f of r into j vector, dou by dou z of f of r into k vector, right? So differentiate this. So remember, here r is a function of x, y, z. You can see this r is a function of x, y, z, right? So don't treat r as a constant here, right? So here r is a function of x, y, z. You can see r is equal to in terms of x, y, z, right? So don't think r is a constant here. So what is dou by dou x of f of r? So this will be f dash of r into dou r by dou x. Right, we are considering partially. This is independent of this is in terms of r. So this will be f dash of r into dou r by dou x, right? So into I vector plus this will be f dash of r into dou r by dou y into j vector. Now differentiate this. This will be f dash of r into dou r by dou z into k vector. So I can take f dash of r outside. So we take f dash of r outside, we will be having dou r by dou x I vector, dou r by dou y j vector, dou r by dou z into k vector. So what is this? This is nothing but gradient of r, right? This is nothing but gradient of r. So gradient is this. So if we replace f by r, so we will have gradient of r. So we have proved the first we have proved the first identity, that is gradient of f of r is equal to f dash of r into gradient of r, right? So we're going to prove 6 things now. So first thing is grade of f of r is f dash of r into grade r, right? F dash of r into grade r. So I'll move on to the next identity. Next thing, gradient of r is 1 by r into r vector, right? So we need to prove gradient of r is 1 by r into r vector, right? So we'll prove this. Okay. So what is grade f? So grade f is dou f by dou x into I vector, dou f by dou y into j vector, dou f by dou z into k vector, right? So that will be, what is grade r? So grade r will be dou r by dou x I vector, dou r, okay, so I write it in this way. So it will be dou by dou x of r into I vector, dou by dou y of r into j vector, dou by dou z of r into k vector, right? Remember, r is a function of x, y, z here, right? So we know r is root of x square plus y square plus z square, right? Because r is modulus of r vector. So what will be this? So when I differentiate r, it will be 1. So 1 into dou r by dou x, right? 1 into dou r by dou x into I vector. When I differentiate r, we will have 1 into dou r by dou y, right? This is normal differentiation. We here r, but we have with respect to y we are doing. So differentiate this r and we put dou r by dou y into j vector, 1 into dou r by dou z into k vector, right? But we don't know dou r by dou x, we don't know dou r by dou y, we don't know dou r by dou z, right? We need to find these 3. So this is what? This is dou r by dou x into I vector, dou r by dou y into j vector, dou r by dou z into k vector, right? We don't know these three things. We will find this. So we have r to be equal to root of x square plus y square plus z square. So that means what will be r square? So r square is x square plus y square plus z square. So differentiate partially with respect to x. Differentiate partially with respect to x. So this will be 2r dou r by dou x, right? With respect to x we are differentiating. So differentiate r square and you put dou r by dou x, and this will be 2x and this will be 0 0. So these 2 will get cancelled. So this implies dou r by dou x will be equal to x by r. So similarly you differentiate partially with respect to y. So this will be 2r dou r by dou y. That is, I'm differentiating this, right? I'm differentiating this star partially with respect to x and with respect to y now. So 2r dou r by dou y. So the derivative of x square is 0, y square will be 2y, this will be 0, this 2 will get cancelled. So that means dou r by dou y will be y by r. Now similarly, you differentiate partially, that is, I'm differentiating star, right? I'm differentiating this star partially. Differentiating this star partially with respect to z. So 2r dou r by dou z. Here we will have 2z. This 2 will get cancelled. So dou r by dou z will be equal to z by r. So substitute all these value here. So dou r by dou x is x by r I vector. This will be y by r j vector. This is z by r into k vector. Take this 1 by r outside. So we will have xi vector plus yj vector plus zk vector. So this will be 1 by r. This is nothing but r vector, right? That means this is the one we need to prove. So 1 by r into r vector. So grade of r. So gradient of r is 1 by r vector. What is r? R is root of x square plus y square plus z square. So we need to find dou r by dou x, dou r by dou y, dou r by dou z. So I'm taking we know r is root of x square plus y square plus z square. So r square will be x square plus y square plus z square. Differentiate partially with respect to x, y, z. You will have dou r by dou x, dou r by dou y, dou r by dou z, right? So we have proved two things as of now. So the third thing is, so prove that so gradient of f of r cross r vector is equal to 0, right? Gradient of f of r cross r vector is equal to 0. So we'll prove this, right? Now we already from 1 we already know what is gradient of f of r. So from 1 we already know gradient of f of r is f dash of r into delta r, right? F dash of r into delta of r, right? F dash of r into delta r. So I'm just go and also from 2 we know what is gradient of r. It is 1 by r into r vector, right? 1 by r into r vector. This is the from 2. So what I'm going to do is I'm going to substitute this value here, right? So therefore gradient of f of r will become f dash of r. Actually gradient of f of r is f dash of r into del r. So instead of del r, what I'm going to do is I'm going to replace by 1 by r into r vector. So that means I can write this delta of f of r to be f dash of r 1 by r vector, right? Okay. Now so therefore, so delta of f of r cross r vector, this is equal to, so I'm going to find the value of this LHS part. So as of now, what we have just did is we have simplified delta of f of r. So I'm going to write delta of f of r to be equal to f dash of r 1 by r vector into r cross, right? So instead of this f of r, I have done this. Now this can be written as, you can see f dash of r, right? So f dash of r, this is nothing but r cross r, right? You can see r is root of x square plus y square plus z square. So overall it's going to be a scalar. This is also a scalar, right? So we will be having r cross r. So we know this is always 0, right? Because when you do r cross r, R cross R, what will be A cross B? A cross B is I, J, K, A vector component, B vector component. So if you do R cross R, the second row and third row will be same. So in expand determinant will be 0, right? So cross product of two same vector will always be 0 because the second row and third row both will be same. So as a result, when the two rows are same, the determinant is always 0. So therefore, R cross R. So R cross R is 0. So it will be approved. Delta of f of R cross R vector is 0. Right? So as of now, we have approved three identities. That is delta of f of R is f dash of R into del R. Del R is 1 by R vector. Delta of f of R cross R vector is 0. Right? Now we'll move on to fourth. So delta of 1 by R, this gradient of 1 by R is equal to minus R vector divided by R cube. Right? This one we need to prove. Solution. So gradient of 1 by R. So directly write this. So what is gradient of 1 by R? So it is dou by dou x of 1 by R into I vector. Grade f is dou f by dou x. So instead of f, you put 1 by R. This will be dou by y of 1 by R into j vector. Dou by dou z of 1 by R into k vector. Right? So differentiate this 1 by R. So derivative of 1 by R is minus 1 by R square into dou R by dou x, right? Because represented with respect to x into I vector. And the derivative of 1 by R is minus 1 by R square into dou R by dou y j vector. And this will be minus 1 by R square dou R by dou z into k vector. So if I take this minus 1 by R square outside, we will be having dou R by dou x I vector, dou R by dou y j vector, dou R by dou z into k vector. Now we already know dou R by dou x value, dou R by dou y, dou R by dou z, right? I don't want to write that again. You can see we have already found, right? If x is root of x square plus y square plus z square, you differentiate with respect to x partially, with respect to y partially. Dou R by dou x is x by R, y by R, z by R. So I'm just going to substitute directly here. This is x by R into I vector. This is y by R into j vector. Z by R into k vector, right? So what we can do is we take this 1 by R outside. This will be 1 by R cube xi plus yj plus zk. This is R vector. So minus R vector divided by R cube. This is what we need to prove, right? So refer subdivision 2, right? So in subdivision 2, we have proved dou R by dou x is x by R, dou R by dou y is y by R, dou R by dou z is z by R, right? So we'll move on to the fifth identity. So del gradient of log R is plus R vector divided by R square, right? So we need to prove gradient of log R. Gradient of log R is R vector by R square, right? Okay, we'll prove this. So what is grade f? Grade f is dou f by dou x into I vector, dou f by dou y into j vector, dou f by dou z into k vector, right? So what will be grade of log R? So this will be dou by dou x of log R into I vector, dou by dou y of log R into j vector, dou by dou z of log R into k vector. So what is derivative of log R? It is 1 by R into dou R by dou x into I vector, 1 by R dou R by dou y into j vector, 1 by R dou R by dou z into k vector. So if I take this 1 by R outside, we will be having dou R by dou x I vector, dou R by dou y j vector, dou R by dou z k vector. And we already know the value of dou R by dou x, dou R by dou y, dou R by dou z. So what I will do is I'll just substitute this directly. This is x by R I vector, y by R j vector, z by R k vector. So we just take this 1 by r outside. So we'll be having 1 by r square xi plus yj plus zk. This is r vector by r square. This is what we need to prove, right? So we move on to the sixth subdivision, which is the last subdivision in this. So gradient of, actually all these 6 things are UPSC questions, right? So all these 6 things are UPSC question. So gradient of f of r is m dash of r into del r. Okay. So gradient of r power n. Gradient of r power n is n into r power n minus 2 into r vector, right? Into r vector. Okay. So gradient of r power n is n r power n minus 2 into r vector, right? So we will solve this. So next we are going to move on to the very, very interesting concept, right? So don't move away. Next concept is very, very important. Rather than important, it will be very interesting. So delta of r power n. Okay, solution. So what is grade f? Grade f is, so grade f is dou f by dou x I vector, dou f by dou y j vector, dou f by dou z into k vector. So we need to find grade of r power n, which is dou by dou x of r power n into I vector, dou by dou y of r power n into j vector, dou by dou z of r power n into k vector. So differentiate this should be n into r power n minus 1 into dou r by dou x, right? Derivative of r power n is n into r power n minus 1 dou r by dou x into I vector, n into r power n minus 1 dou r by dou y into j vector, n into r power n minus 1 dou r by dou z into k vector. So you just take n r power n minus 1 outside. So we'll be having dou r by dou x I vector plus dou r by dou y j vector, dou r by dou z into k vector, and we already know all these values. So n into r power n minus 1, this is x by r I vector, y by r j vector, z by r k vector. So take this 1 by r outside. So n r power n minus 1 by r. This will be xi vector plus yj vector plus zk vector. Take this r to the numerator. So we'll be having r power n minus 2 into r vector. This is what we need to prove. So you say any doubt up to now? Can you move on to the next topic? So as of now, we have put 6 subdivision under gradient. Is there any doubt up to now? Let's save this. Okay, thank you. Okay. So next we are going to move on to the next subtopic. As of now, we have seen gradient, right? Okay. So we're going to move on to some definitions now. So next topic is called level surface, right? It is called level surface. So it will be very interesting. So we're going to define what is meant by level surface. So for 3D, we're going to talk about the tangent plane at a point and a normal line to that point, right? So for 3 dimension, we are going to talk about the tangent plane and a normal line. Okay. So first, what we'll do is this is subtopic under gradient divergence curve. We are getting into the subtopic 2, right? Okay. So it is called level surfaces. So level surface, right? So first we will define what's the level surface, and then we will proceed. And then we're going to actually what the idea is, we're going to define what's the level surface, and then we're going to find the equation of tangent plane and a normal for a level surface at a point, and then we're going to do some problems, and also we're going to talk about directional derivatives, right? Okay, so level surface. So let f of x comma y comma z be a scalar field, over a region R, right? The point satisfying the points satisfying an equation of the type f of x comma y comma z is equal to c. This c is some arbitrary constant. This c is an arbitrary constant. Constitute a family of surface. In a three-dimensional space. In a three-dimensional. No, scalar point function is same as scalar field, right? Scalar point function. Actually, R is a field, right? Yes or no? R is a field. Group theory, ring theory, field theory. So output will be scalars that will form. Output will be a scalar that will be a real number also. So scalar point function. That's it. So constitute a family of surface in a three-dimensional space. The surface of this family are called the level surface. Right? So what is level surface is, let f of x comma y comma z be a scalar valued function, right? So it is a scalar valued function, scalar point function. It's a scalar point function over a region R. The point satisfying an equation of the type f of x comma y comma z is equal to c constitute a family of surface in a three-dimensional surface. The surface of this family is called a level surface, right? This seems to be very bit tricky, right? Can you give me an example of a level surface? You have come across this very often, right? Remember, you need to fix C, right? You need to fix C. You give any function, right? For example, let us say C to be let us say x comma y comma z is equal to 1. I am fixing C to be equal to 1, and I am taking f of x comma y comma z is equal to 1. So what are the points that will satisfy this equation? So there are infinitely many points that will satisfy this, right? For example, if I take x to be equal to 1 by 2, y to be equal to 2, z to be equal to 1, this will satisfy because x into y into z is 1. And similarly, if I take this to be equal to 1 by 3, this to be equal to 3, this to be equal to 1, this will satisfy this equation. And there are infinitely many points, right? If I take this to be equal to 3, this to be equal to 1 by 3, if I take this to be equal to 1, this will satisfy this equation. If I take 1, 2, 1 by 2, again this will satisfy this equation. So you fix C to be equal to some constant. You have a function of 3 variable. You collect all those points that satisfy this equation. So all these points will form a surface. That surface is called level surface. Is it clear now? So you fix an arbitrary constant. You have a function of 3 variable. You collect all those points that satisfy this equation. That all those points will form a surface in a 3D space. That surface is called level surface, right? So actually, we have seen many examples of level surface, right? Can you give me another example of level surface that we come across very often? Yes. Can you give me an example of level surface? Actually, you can Okay, I think I shouldn't have erased. Okay, let it be like this. So all these points will satisfy, right? So these infinitely many points will form a surface, right? That is called level surface. I'm going to give you a very common every sphere is a level surface, yes or no? Sphere is a level surface, right? A sphere with the center at origin, or is the equation x square plus y square plus z square. Let us take radius to be equal to 1. This is a level surface, yes or no? X square plus y square plus z square. This function of three variable. Actually, we are talking in three dimension, right? So for circle with center at 0, 0, radius 1, we don't have z square. We are talking about sphere here. So sphere is a level surface, right? So I'm taking radius to be equal to 1, center to be 0, 0, 0. So in general, any sphere with x minus h whole square, y minus k whole square, z minus, let's take another variable, hk, let us take this as p whole square is equal to r square. This is again a level surface, right? So x square plus y square plus z square is equal to 1. And what about ellipsoid? It's also a level surface, right? X square by a square plus y square by b square z square by c square is equal to 1. Ellipsoid, again level surface. We have function of x comma y comma z, and we are fixing an arbitrary constant. You need to collect all those points that satisfy this equation that will form a surface in 3D. That surface is called level surface. What about this? A level surface. What are the points that will satisfy this equation? All those points in the sphere will satisfy this equation, right? So, for example, let us try to draw this diagram, right? Let us say let us try to draw this diagram here. So, what are the points that will satisfy x square plus y square plus z square is equal to 1? It's nothing but a sphere. So let us try to draw sphere. I don't know why I'm getting the window here. Okay, so let us try to uh, draw this diagram path is right. X square plus y square plus z square is equal to 1. I'll just draw some rough diagram. Right, so I'll just with this is a sphere. You can see all these points will satisfy the equation x square plus y square plus z square is equal to 1. So you can see all these points will satisfy this equation x square plus y square plus z square is equal to 1. And this forms a surface in 3 dimensions, right? So this is called a level surface, right? And similarly, you can draw diagram for this also. So this is called level surface. Okay. Is it clear? So we have function of very simple. We have function of three variable. We are fixing that to be equal to some constant. You collect all those points that satisfy the equation. All those points will form a surface that is called level surface. For example, I have given one example, x y z is equal to 1. That will be some diagram. So we will be, if I take the known example, let us take a sphere with center 0, 0, 0, radius to be equal to 1. You collect all those points that satisfies this equation. For example, 0, 0, 1 will satisfy, 1, 0, 0 will satisfy, 0, 1, 0 will satisfy. So there are infinitely many points will satisfy. So all these points form a surface that is called level surface, right? Okay. Now what we're going to do is, the next thing is what we're going to do is for a level surface, we are going to find the tangent plane. Um, um, we are going to find the tangent plane and normal line for this level surface, right? So what we're going to do is we are going to find the tangent plane at a point P, right? So first let us take a point P. Let's say this is a point P. Let's say this is a point P. Now what we're going to do is we are going to find the tangent plane. So what is tangent in 2D? A line that touches the curve at only one point. But here we will talk about tangent plane. So we need to find a plane that touches this surface only at P, right? So I'll just draw this diagram. So just try to visualize this, right? So we need to find a tangent plane that is above this, that touches the point P, right? So it is very hard to visualize, but try to do. Right? So you just see this in top view, right? See this in top view. We are going to find the equation of this plane. This is the tangent plane, right? This is the tangent plane at P. This is the tangent plane at P. So we are going to find the equation of this plane. This is what the next aim is, right? So our next aim is to find the tangent plane, equation of tangent plane at a point P to the level surface, right? So we have a level surface like this. I think camera is visible. So let us say this is our level surface. So we are going to find the tangent plane to this level surface, right? So what is the equation of this tangent plane? That is what we are going to find now, right? This will be very interesting to find the equation of this tangent plane. So first what I'll do is I'll give you the formula. I'll give you the formula for tangent plane directly. For tangent plane and normal, you know what is normal, right? So normal is a line that is perpendicular to tangent. So you can see normal will be like this, right? So normal line, that is a line that is perpendicular to tangent plane, right? That is perpendicular to tangent plane. So what we're going to do is we are going to find the equation of tangent plane, and also we are going to find the equation of normal line. I'm going to give that formula directly first, and then I'll explain how that formula came, right? Because it is not good to give only formulas. I'll tell you how it came. So before that, first I'll give you the formula directly. By adding formula is more than enough, but I'll let you know how that formula came also, right? Okay. So the next topic is tangent plane and a normal line. Tangent plane and normal line. This equation of tangent plane, right? Tangent plane and a normal line at a point P. At a point P, let us call that point to be x comma y comma z. Tangent plane to a level surface, right? To a level surface. We are going to find the equation of tangent plane and normal line at a point P to a level surface. Yes, I'll let you know. I've learned math, physics with maths, right? I'll let you know. You were asking some question about, sir, is it a surface of constant potential? You don't know physics, right? So I'm not getting that question. Okay. So tangent plane and normal line at P x comma y comma z to a level surface. Okay. So we're going to find the equation of, actually this is one f of x comma y comma z. We're going to generalize this for all. This is P here. So just for understanding, I will draw the diagram here, right? Okay. So first I'll give you the formula directly, right? To find the equation. To find the equation of tangent plane and normal line at P, right? At a point P to the surface f of x comma y comma z is equal to c. We are going to find the tangent plane and normal to the level surface. So tangent plane at P tangent plane at P, the formula is capital X minus x dou f by dou x plus capital Y minus small y. This is capital X, right? So capital X minus x, capital Y minus small y into dou f by dou y, capital Z minus small z into dou f by dou z is equal to 0 is the equation of tangent plane, where this capital X, capital Y, capital Z are point in the surface, right? So we have some arbitrary point x comma y comma z in the surface, that is capital X, capital Y, capital Z, and the small x, small y, small z is the point that we are talking about, right? The small x, small y, small z is the we are talking about at that point, and this capital X, capital Y, capital Z is some arbitrary point in the surface, right? Okay, this is the equation of tangent plane. Now, equation of normal line. So, equation of normal line at P. So, in exam point of view, this is, I think this is enough, but I let you know how this formula came, right? Because it is not good for me as a teacher to just give you the formula. So, I'll just let you know how this formula came. And the equation of normal line at P is given by capital X minus x divided by dou f by dou x, capital Y minus small y, dou f by dou y, capital Z minus small z divided by dou f by dou z. So in exam point of view, you just remember these two things, right? So equation of tangent plane at a point P to the level surface f of x comma y comma z is capital X minus small x. So this small x, small y, small z is the point that they will give in exam point of view. They will give f also. So you just have to substitute this small x, small y, small z here, and you differentiate f with respect to x, with respect to y, with respect to z. You keep capital X, capital Y, capital Z as it is. That will be the equation of tangent plane, right? Okay. So now what we will do is I let you know how this formula came, right? I let you know how this formula. As of now, is it okay? Everything is good, right? As of now. So we are defined what is the level surface. We are talking about the tangent plane and a normal line for the level surface at a point P. So as of now, I've given you the formula. Now I'm going to let you know how this formula for tangent plane and the normal line came, right? So we need to prove how this formula came, right? Okay. So to find the equation of tangent plane and normal. So let us say we have a surface f of x comma y comma z. So here we can sphere. Let us take some arbitrary surface. Let us take a surface like this, right? Let us take some surface. So this is f of x comma y comma z is equal to c. F of x comma y comma z is equal to c, right? Okay. Now what I'll do is, let us take a point P in this surface, right? We are going to find the equation of tangent plane and a normal line to this surface. So what I want to do is let us draw a position vector to P, right? Let us draw a position vector to P. And this is a position vector OP, right? Let us say this R vector. Let us say this R vector. Now, what is R? I'm going to write R vector in parametric form. So this will be x of t into I vector, y of t into j vector, z of t into k vector, right? So whenever we need to derive something, you always write it in parametric form. So x of actually R will be xi plus yj plus zk. So I'm just going to write it in parametric form. So x of t, y of t, z of t into k vector, right? So this is x of t I vector, y of t j vector, z of t k vector. So what about this coordinate? So this coordinate will be x of t, y of t, z of t, right? Very simple. If this is xi plus yj plus zk, this point will be x comma y comma z, right? So this point is x of t, y of t, z of t. Now this point lies in the surface, right? So let us write that here. So we have f of x comma y comma z to be equal to some constant, right? Now this point P lies in the surface. That means what? Instead of x, y, z, if you substitute x of t, y of t, z of t, that point will also satisfy this, right? This implies f of x of t, y of t, z of t will also satisfy this equation, right? Because this point lies in the surface. Okay. Now you differentiate, right? So when you differentiate this, so here I'm going to use chain rule because we have function of x is a function of t. So if I differentiate this f dash, right? If I differentiate this, we will be having this to be equal to dou f by dou x, dou f by dou x into dx by dt, dou f by dou y into dy by dt plus dou f by dou z into dz by dt. This will be 0, right? Because derivative of constant is 0. So I'm just differentiating this differentiating this. I'm using chain rule, right? I'm using chain rule. So x is a function of t. This is normal chain rule that we come across in 12th standard. So we have dou f by dou x dx by dt, dou f by dou y dy by dt, dou f by dou z dz by dt, right? Okay. Now we have, okay, can I write this as dou f by dou x I vector, dou f by dou y j vector, dou f by dou z k vector dot dx by dt I vector, dy by dt j vector. The proof is only for your clarity, right? So in exam point of view, just why are these two things? But I'm just giving proof just to give you a concept understanding. So dz by dt into k vector, I can write like this, right? Because when you make a dot product, you will get this thing, dou f by dou x into dx by dt plus dou f by dou y dy by dt plus dou f by dou z dz by dt. Now this is nothing but, what is this? This is gradient of f, right? So this is nothing but gradient of f dot, right? I'm making dot product here. What is this? This is the derivative of r vector. So this is dr vector by dt. Yes, dr vector by dt is equal to 0. Yes or no? So this is r vector. So dr by dt will be dx by dt. So what about dr vector by dt? This is dx by dt I vector. Okay, got it. Write it here. So we have r vector to be equal to x of t I vector, y of t j vector, z of t into k vector. So what about dr vector by dt? It will be dx by dt I vector, dy by dt j vector, dz by dt k vector, right? So this is grade f, this is dr by dt. So as of now, what we have inferred is grade f and dr by dt are perpendicular at this point P, right? This implies, sorry, this implies grade f, right? This implies grade f and dr by dt are perpendicular, yes or no? Whenever the dot product is 0, those two vectors are perpendicular, right? So dr by dt are perpendicular, that is angle between them is 90 degree. As of now, we have inferred this. What we have inferred is grade f and the derivative of r vector both are perpendicular. That is what we have inferred as of now, right? Okay. Now, what is our aim? Our aim is to find the equation of tangent plane. We haven't even come to that, right? Now we are going to come to that now. So let us draw this diagram once again. As of now, what we inferred is grade f and dr by dt are perpendicular, right? That is what we have inferred as of now. Right? Okay. As of now, that is what we have inferred now, right? Okay. Now what I'm going to do is I'm just going to draw this diagram once again, but I'm going to take only the takeaways, right? I'm just going to draw. Okay. Let us redefine the equation of tangent plane, right? Let the tangent plane be like this, right? Okay. So you see, let us this is a tangent plane. So it is very hard to draw diagram for the 3D surface. Let us say this is a point P, right? P of x comma y comma z. So what I did is I have just taken a point P. Actually, we need to draw tangent plane for this, right? Tangent plane to this point P. So I'm just taking this diagram alone, right? This tangent plane and this point P. I'm just taking that alone. So this is the position vector that we have, right? This is the position vector that we have. This is R. This is R vector. Now, actually, this is some curve, right? This is some curve. Okay. Now, what about dr? What about dr by dt? This is r vector. Dr derivative of this is the tangent plane at this point P, right? So let this be dr by dt, right? Actually, there will be some curve connecting this, right? There will be some curve connecting this. So we will find dr by dt. So dr by dt is the slope of this point. Let us say this is dr by dt, right? So I'm just drawing a tangent plane at this point P. This is R. So dr by dt, right? Okay. So it's very hard to visualize in 3 dimension. So you are getting my point, right? So I'm just drawing the slope, that is a tangent line at this point. This is dr by dt. Now we need to find the equation of this tangent plane, right? This is dr by dt, and we know that the grade f and dr by dt are perpendicular. So this is dr by dt. So therefore, grade f has to be somewhere around here, right? This is grade f. and these two are perpendicular, we know, right? These two are perpendicular, that we have already inferred, right? So that this tangent vector and grade f both are perpendicular, that we already know. Okay, now what I'm going to do is I'm going to take an arbitrary point here. Let us call this point to be some p naught. Let us call that to be capital X, capital Y, capital Z. That is what I have said here. This capital X, capital Y, capital Z are some point in the surface. So I'm taking this that to be equal to some p naught. Now remember, if I join p naught, this p naught lies in the tangent, lies in the plane. Yes or no? This p naught lies in the plane. Now this del f is perpendicular to plane. That means it will be perpendicular to every line in the plane. So we have p naught and delta f are perpendicular, right? So very simple, right? So this is tangent plane and this del f is perpendicular to the plane itself. That means it will be perpendicular to every line in the plane also. So p naught will be perpendicular to del f. So we have p naught is per, or you can also write this as some q, right? If you want some clarity. Okay, let us call this point to be some q, right? Let us call this point to be some q. This q is some arbitrary point in the surface. So I'm just taking that to be a parametric form. Okay, I'm just parametric. I'm just finding that in parametric form. Okay, so we have PQ is perpendicular to del F, right? PQ is perpendicular to del F. Now, what is PQ? What is PQ? PQ is the line joining these 2 points. So we have PQ to be equal to capital X minus small x I vector, capital Y minus small y j vector, capital Z minus small z into k vector, right? So x minus x, y minus y, z minus z. And we know del F. So del F is dou F by dou x I vector, dou F by dou y j vector, dou F by dou z into k vector. So when these two are perpendicular, that means PQ dot del F will be 0. So when you make a dot product, so we will be having the equation of tangent plane. So x minus x, dou F by dou x, y minus y, dou F by dou y, capital Z minus small z, dou F by dou z is equal to 0 is the equation of tangent plane at P for a level surface f of x comma y comma z is equal to c, right? So in exam point of view, you just memorize the formula, right? Capital X minus small x, dou F by dou x, capital Y minus small y, dou F by dou y, capital Z minus small z, dou F by dou z is equal to 0. Now we will find the equation of normal line also. So normal line is very easy, right? What is normal line? So for normal line, what I'm going to do is write it here itself, right? So for normal, so let us take a point P naught here itself, right? Let us take a point P naught. Let's call this to be x comma y comma z, right? We need actually we know we know we know grade f will be normal, but we don't know the equation of this, right? Okay. Now this P naught for tangent plane, I have taken a point Q in the surface. Now I'm taking a point P naught here. Now you can see this P naught and this grade f is parallel. Yes or no? We need to find the equation of this, right? A normal line is a line that is perpendicular to tangent plane and passing through that point P. So we have this P naught is parallel to del f. Yes or no? So these two are parallel. So very hard to visualize, right? You need to visualize in three dimension. So this P naught and del f are parallel. And what is P naught? P naught is same, right? The same x minus x I vector capital X minus small y j vector capital Z minus small z into k vector is parallel to del f, right? So del f is dou f by dou xi, dou f by dou y. Now two vectors are parallel. If that is two vectors are parallel, if a vector can be written as some lambda times b vector, right? These are very standard formula, right? So two vectors are parallel. Two vectors are parallel if a vector is equal to lambda times b vector. Now these two vectors are parallel. So these two vectors are parallel. That means I can write this as P naught is equal to some lambda times gradient of f. Now what is P naught? Capital X minus small x. Sorry, capital X minus. Okay, I'm facing this problem with capital. Okay, this equation. Okay, P naught is equal to lambda times del f. This is x minus x into I vector, capital Y minus small y j vector, capital Z minus small z into k vector is equal to lambda times del f, dou f by dou x I vector, dou f by dou y j vector, dou f by dou z k vector. So you just equate the coefficient of x, y, z, equate the coefficient of I, j, k. So we will be having capital X minus small x to be equal to lambda times dou f by dou x. Capital Y minus small y is equal to lambda times dou f by dou y. Capital Z minus small z is equal to lambda times dou f by dou z, right? I'm just equating the quotient of I, j, k. So that means capital X minus small x divided by dou f by dou x is equal to lambda. Capital Y minus small y divided by dou f by dou y is equal to lambda. Capital Z P naught, right? I've taken a point P naught here. I've taken a point P naught. Here I've taken PQ, right? Okay. So Z minus Z is divided by dou f by dou z is equal to lambda. So all these are lambda. That means capital X minus small x divided by dou f by dou x is equal to capital Y minus small y divided by dou f by dou z. Capital Z minus small z divided by. No, PQ is not parallel to del f. PQ is perpendicular to del f. P naught is parallel to del f. So you can see this PQ is perpendicular to del f. This is 90 degree. But this P naught is parallel to del f. PQ is perpendicular to del f. You can see I have written perpendicular. This is perpendicular, right? And this means parallel. Okay. So we have dou f by dou z is the equation of right. So this is how we have got these two equations. So in exam point of view, you just remember these two things, right? So we'll do some problems based on this. Problem will be very easy, right? Just have to by heart these two formulas, and then you have to substitute in the substitute here. That's it. Before that, I'll give you two notes based on this. I don't know where written P dash. Some people are talking about P dash. I don't know where written P dash. So I've written B, P naught, Q. Okay, so I'll give you a note. Angle between the two surfaces at a point. Angle between the two surfaces at a point is the angle between the normal to the surface at the point. Right, so angle between two surfaces is nothing but angle between the normals to the surface, right? So make this note. Okay, we'll do some problems based on this. Find the equation of tangent plane and a normal to the surface x, y, z is equal to 4 at the point 1, 2, 2, right? So find the equation of tangent plane and normal to the surface. So we have f of x, y, z. We have f of x, y, z to be equal to x, y, z minus 4 is equal to 0, right? Now what we need to do is, first we will find the tangent plane. Problem is very easy, right? Tangent plane at P. What is P? P is 1, 2, 2. So what is formula? Capital X minus small x, dou f by dou x, capital Y minus small y into dou f by dou y, capital Z minus small z into dou f by dou z is equal to 0. So what about dou f by dou x, dou f by dou y, dou f by dou z? So okay, before that what we will do is okay. So before that we will find dou f by dou x, dou f by dou y, dou f by dou z. So dou f by dou x, dou f by dou y, dou f by dou z, right? Let's check the question once again. Is x by z is equal to 4. Okay. So what we'll do is we will find grade f. So what is grade f? It is dou f by dou x I vector, dou f by dou y j vector, dou f by dou z into k vector. Actually, you can also, this is in Cartesian form, right? It is in Cartesian form. So if you want to write this in vector form, so it will be r minus small r dot del f is equal to 0, right? So this r is xi plus yj plus zk, and the small r is the one, the point that we are finding, right? Small xi, small yj, small zk. We can also write this also, right? So del r minus r dot del f, both are same, right? Both are same. Capital R is the one, the arbitrary point, that is capital X, capital A, capital Z. So we want to write it as vector capital Xi, capital Yj, capital Zk, and small r is the point that we are finding, right? Here small r is the point P, which is XYZ. Okay, so we will find dou f by dou x. What is f of x comma y comma z? It is XYZ. So what is dou f by dou x? So you differentiate with respect to x, so it will be yz into I vector with respect to y, xz, sorry, this is j, into j vector with respect to z, xy into k vector. Now you find del f at 1 comma 2 comma 2. So gradient of f will be at 1 comma 1 at 1 comma 2 comma 2. So this will be y into z. So this will be 4i vector x into z. So 1 into 2. So 2j vector x into y, so it will be 2k vector, right? That means this implies dou f by dou x is 4, dou f by dou y is 2, dou f by dou z is 2, right? Because grade f is dou f by dou x I, dou f by dou y j. Just compare this, right? So we have found dou f by dou x, dou f by dou y, dou f by dou y z. So let us call this as 1. So 1 becomes, so you find gradient of f at this point. After that, equate the coefficient of x, y, z will be dou f by dou x, dou f by dou y, dou f by dou z. So this will be capital X minus small x, dou f by dou x, capital Y minus small y, dou f by dou y, capital Z minus small z, dou f by dou z is equal to 0. So capital X minus small x comma y comma z is the point that we are taking. We are taking at 1 comma 2 comma 2. That is, we are finding the tangent and normal at this point. So it will be x minus 1, dou f by dou x is 1, sorry, 4, plus capital Y minus small y, dou f by dou y is 2, capital Z minus small z is 2, dou f by dou z again is equal to 0. So this will be 4x minus 4, 2y minus 4, 2z minus 4 is equal to 0. So we will be having 4x plus 2y plus 2z. So minus 4 minus 4 minus 4 will be minus 12 is equal to 0 is the equation of plane. It is the equation of plane, right? If you have seen analytical geometry, what is the general equation of plane? Ax plus by plus cz plus d is equal to 0, right? So what is the general equation of plane? Ax plus by plus cz plus d is equal to 0. So we have already completed planes, right? Ax plus by plus cz plus d is equal to 0 is the general equation of plane. This is the equation of tangent plane, right? It's the equation of tangent plane at the point P. So what about the equation of normal? So it will be x minus x divided by dou f by dou x, capital Y minus small y divided by dou f by dou y, capital Z minus small z divided by dou f by dou z. So small x is 1, this will be 1, capital Y minus small. Remember this capital small x, small y, small z is the point that they are giving, right? 1 comma 2 comma 2, and we already found dou f by dou x, dou f by dou y, dou f by dou z. Right? So this is the equation of normal line. This is the equation of line, right? The equation of normal line. That's it. So that is why I'm saying problem is very easy unless if you know these two formulas. Capital X, capital A, capital Z will remain as it is. Small x, small y, small z is the point that they are giving. So you just find dou f by dou x, dou f by dou y, dou f by dou z. You find gradient for the function and you substitute this point and the coefficient of I is dou f by dou x, coefficient of y is dou f by dou y, coefficient of j is dou f by dou y, and the coefficient of z is dou f by dou z, right? Yes. So I'll give you one problem for exercise for you, right? After that, we'll continue in the next class. So find the equation of tangent plane and a normal to the surface x square plus y square plus z square is equal to 25 at the point 4 comma 0 comma. How that 4 come where 4? This is dou f by dou x. So dou f by dou x is 4, dou f by dou y is 2, dou f by dou z is 2. So here we have 4, 2, 2. And small x, small y, small z is 1, 2, 2. So small x is 1, small y is 2, small z is 2. Is it clear? Priyanka. Okay. So you take this exercise, right? I think you can do this problem very easily, right? So you just take f of x comma y comma z to be equal to x square plus y square plus z square minus 25. So find gradient of f, substitute this point, you will have dou f by dou x, dou f by dou y, dou f by dou z. And here our small x, small y, small z is 403. You can easily do this, right? I'll just give you the answer. So the equation of tangent is 4x plus 3z minus 25 is equal to 0. See, this is del f, right? This is del f. And just compare this and this. Just compare this and this. So what is the coefficient? What is dou f by dou x? It is 4. Right? Just compare these coefficients here. And just compare this. Dou f by dou y is 2. Dou f by dou z is 2. Just compare these two, right? To find dou f by dou x, dou f by dou y, dou f by dou z. Just compare these two. Because here we have ijk, here we have ijk. Compare this, you will get dou f by dou x, dou f by dou y, dou f by dou z. So equation of normal is given to be capital X minus 4 by 4, capital Y by 0, capital Z minus 3 by 3. I think I do this problem right. I don't want to do this, right? So you just find gradient at that point, equate the coefficient of ijk will be dou f, dou f, dou f, dou y, dou z. And we small x, small y, small z, just have to substitute that directly in the formula. Okay, so is there any doubt up to now? So we'll stop here, we'll continue the next class. So we'll do some more problems based on the tangent plane and normal to the level surface. So in exam point of view, they will ask question only like this. So you just have to buy out the formula for the tangent plane and the normal line. So which is capital X minus small x, dou f by dou x, capital Y minus small y, dou f by dou y, capital Z minus small z, dou f by dou z. And for normal, capital X minus small x divided by dou f by dou x, and so on. So you just do these two problems. So practice second problem, we'll get the answer for tangent to be 4x plus 3z minus 25 is equal to 0, and a normal to be x minus 4 by 4 is equal to y minus 0 is equal to z minus 3 by 3. The next class we'll do more problems on this, and also we're going to introduce what is meant by directional derivative. After that we'll be moving on to next topic, which is called divergence, right? The topic that we are seeing is gradient, divergence and curl. So we have finished gradient. After that we have started level surface, tangent and normal to level surface. So we will continue in the next class, right? Thank you, bye.